So what we're going to do today, actually, we're going to probably understand Ethereum. We're going to understand how smart contracts work. We're going to see, identify cryptocurrencies used in Ethereum, describe transactions in Ethereum, define consensus mechanism in Ethereum. Let's take some of the development technologies, we are currently using today. Some of the clients which we are using actually for development work, platform functions. We're going to touch upon that. Ethereum. Okay, let's know more about Ethereum. Okay, so Ethereum was conceptualized by Vitalik Buterin actually in November 2013. Ethereum is a distributed open blockchain network. The key idea proposed was the development of a tuning complete language that allows the development of smart contracts for blockchain and decentralized applications. Okay. So Ethereum aims to enable actually innovations in 4 areas. Okay. Uh, Certainly currency issuance, which is nothing but ICOs. Smart contracts, as it was introduced directly in Ethereum for the first time as part of, we call it blockchain version 2 also Ethereum. Decentralized autonomous organizations, DAO. Okay. And smart properties, nothing but the assets. Okay. So this is how the Ethereum layers look like. Okay. So these are nothing but your application layer. Okay. You have a smart contract. Okay. You have actually Ethereum virtual machines, EVMs. You have decentralized apps. Okay. Then you have actually reward distribution, which is nothing but your insensitive layer. A reward distribution is nothing but actually for the miners. And transaction fee actually, or the gas actually, which is associated with every transaction what you're doing actually on the Ethereum network. Okay. We have consensus layer where the consensus is achieved actually for every transaction which is flowing on the network. We have two. One is proof of work, which is currently being supported. With the introduction of future Ethereum probably app or the wallets, we'll see actually proof of stake being introduced. We'll talk about more actually when it's getting introduced, with what version of Ethereum is going to get introduced in the later slide. Okay, network layer. Okay, so network layer actually we talked about P2P broadcast. Okay, we talked about actually peer-to-peer broadcast happens actually using Google RPC. It's the same actually in Ethereum as well. Plus we we have something called as Whisper. Gossip protocol. We in Ethereum we call it a Whisper. Okay, local validations actually which is nothing but actually for every transaction which is happening on the network, you have a local validation which is done before the transactions are committed onto the ledger. Okay, the data layer. You have a data block. So we saw actually how the block looks like. What does the block structure look like? Okay, hash functions. So we use actually hash SHA-3 here instead of SHA-2 256 what we have seen at least so far. So in Ethereum we use actually SHA-3 which is actually 512 bits or probably 64 bytes. Okay. Merkle tree, actually we know what is Merkle tree and how Merkle tree operates. Okay. Till the time actually we have the Merkle path that forms your complete chain of transactions which have been embedded actually into the block. Okay. Delta signatures, certainly your public private key, and basically for every transaction actually you put your data signatures just as an identity, like who has triggered the transaction actually, and when the transaction basically who has signed the transaction actually, so that is what an identity to a transaction. Okay, chain structure. So basically nothing but a block of chain actually and we follow the longest chain pattern actually in the Ethereum world as well. Distributed hash table. So what does it mean actually? Every node on the network has their own hash. Okay, and they have actually access to their hash tables actually. Okay, data model actually we have key value pairs actually how the data gets stored. Okay, and then actually we have something called as world state. Okay, we learned actually all of it, nothing new which I'm talking. Cryptographic protocol, nothing but PKI. Okay, public key infrastructure. Okay, that is what is used actually in Ethereum as well. Okay, so Ethereum virtual machines are nothing but actually basically they act as, they are actually nothing but actually distributed nodes which act as actually probably compiling the high level code into low level machine language. Okay, so basically Ethereum typically uses get as the node which has been if you look at it when you installed your Ethereum wallets, By default, actually, you would have seen actually get getting installed. Okay. Typically, actually, get is the preferred uh, underlying uh, language which has been preferred actually on the Ethereum wallets. Get is nothing but Golang. Okay. Which is what actually the EVM does. Actually, it converts the solidity code or any other high-level code actually into the Get. Okay. Decentralized apps is nothing but actually basically the code what you're going to write actually for decentralized nodes, which will be accessible and viewed commonly across the applications. Smart contract, we all know what is smart contract. Smart contract is nothing but actually autonomous code. It basically replaces the third party and the paper contracts actually what we have actually between two counterparties on the network. Okay, so this is all actually what we have actually in terms of Ethereum layers. Okay, building blocks of Ethereum. Okay, so we talked about what is Ethereum virtual machine. So using Ethereum programming language to build a smart contract on any other application, the EVM compiler takes that code, resolves it into a low-level machine language or machine instructions for the Ethereum virtual machine to understand, process, and execute. Okay, peer-to-peer network. Okay, so the Ethereum, the underlying network consists of nodes or computers connected in a decentralized peer-to-peer network. Each node runs as an EVM. This is what we have shown. Okay, and processes the same instructions to ensure that consensus is achieved on any particular transaction. Okay, so we have actually two accounts as part of the Ethereum. Okay, we have something called externally old accounts. We call it EOAs also, controlled by external party or person like you and me. Okay, accessed through private keys, contain ether balance. Okay, I can send transactions as well as trigger smart contracts or contract accounts. We call them actually contract accounts or the contracts as well. Okay. Contract accounts actually basically nothing but like a contract account contains code to execute a particular function that is designed for, and this code lives on the Ethereum blockchain. Once a contract account is triggered, either by externally owned account or by any other contract account, okay, the code inside is executed by the Ethereum virtual machine on each participating node. And these accounts are also known as smart contracts. So by default, actually, you'll have Ethereum comes with actually some underlying contracts which are already deployed. Okay, to make the Ethereum wallet run. Okay, so you'll by default you'll have the contract accounts already installed. If we restrict Ethereum to only externally owned accounts, what will happen if we don't have smart contracts in Ethereum? And allow only transactions between them, we arrive at an alternate coin system that is less powerful than Bitcoin itself and can only be used to transfer Ether. Anything without smart contracts is as good as probably we are having actually probably a Bitcoin itself. And the use case actually of Ethereum actually would be less powerful actually compared to what we have in Bitcoin today. Okay. Okay. So what is smart contract? We'll move on actually. So what is smart contract? The basic building blocks of programs written for the Ethereum platform are called smart contracts. Let's understand what are smart contracts. So a smart contracts is a computerized transaction protocol that executes the terms of a contract. When running on a blockchain, a smart contract becomes like a self-operating computer program that automatically executes when specific conditions are met. I think that's nothing new what we are hearing. An option contract between parties is written as code into the blockchain. The individuals involved are anonymous, but the contract is written in the public ledger. Okay. A triggering event like an expiration date and strike price is hit, and the contract executes itself according to the coded terms. Okay. Regulators can use the blockchain to understand the activity in the market while maintaining the privacy of individual actors' position. Steps to create a smart contract. Smart contracts are contract account that facilitate exchange of value in a transparent and trustless way without the need for a middleman. So here are the steps. A contract account uh, with rules is created. Like example, if this is true, then do that. Contract is then coded in an Ethereum high-level language such as Solidity, syntax similar to JavaScript, and deployed on the Ethereum blockchain. Once deployed, the contract gets a public key address. Okay, that can be used to reach the contract and trigger its code execution. Also, once a smart contract is deployed to the Ethereum blockchain, it cannot be changed even by EOA that created it. So EOA is nothing but externally owned accounts. We saw it in the previous slide. Okay. So EOS could be like you and me. We write the smart contract, we deploy it. Okay, but once it's deployed, nobody can alter it. Okay, gets deployed and gets no, it stays that way. Okay, smart contracts are code that is deployed on the Ethereum blockchain, and this code runs on every single node connected to the Ethereum network. Currency used in Ethereum. Okay, so Ethereum is incomplete without cryptocurrencies. Let's have a look at the cryptocurrency used in Ethereum. Ether. Okay, the esteemed token of the Ethereum blockchain is called Ether. It is recorded under the code ETH and exchanged on a digital currency trades. It is also used to pay for transaction fees and computational services on the Ethereum network. Every time a contract is executed, Ethereum consumes tokens, which is termed as gas, to run the computations. So these are the how you denote of Ether. These are the different ways you might see the Ether being denoted. Y is V is which is the most common denotation actually, which you see actually mentioned everywhere. Kilo by kilo V, or probably like mega V, giga V, micro ether, milli ether, or ether. Okay, so ether is used to purchase gas. Okay, a crypto fuel. Let's understand what is gas in Ethereum system and why is it necessary. So gas is required to be paid for each activity performed on the Ethereum blockchain. Okay, a transaction fee is charged as some amount of ether and is taken from the account balance of the transaction originator. You will be seeing actually test ethers being used actually to deploy a smart contract. When you trigger a transaction from one wallet to other wallet, you'll see the gas being used actually to make the transfer happen actually on the Ethereum platform. And that's where we need ethers actually, test ethers, or probably or in the main network we need actually real ethers for any kind of transaction to happen. And that's where we're going to mine those ethers actually from some of the social networking sites, and we'll show you actually how to do it. A fee is paid for transactions to be included by miners. Okay, the more the fee, the higher the chances that transaction will be picked by the miners for inclusion in the block. Providing too little gas will result in a failed transaction. So let's say transaction would be consuming at least certain amount of gas, but actually if you allocate less than what is recommended by the wallet, Ethereum wallet, your transaction will fail. Okay, it will not be included actually into the block. Assessing actually transaction cost. Transaction cost can be estimated using the following formula. As I said, total cost is nothing but actually the gas used into the gas price. Gas use is the total gas that is supposed to be used by the transaction during the execution. Gas price is specified by the transaction originator as an incentive to the miners. So this is basically what you agree. So in the case of Ether or in Ethereum platform, we have actually 5 Ether actually as the gas price which is defined for every transaction. Oh, sorry, for every block. So there's a tip actually which is given actually to the miners actually is a 5 ether for every block actually what contains the associated set of transactions. Okay. So transactions in ether. The most notable difference between the Bitcoin and Ethereum blockchain is the Ethereum blocks contain both a transaction list and the most recent state of the ledger of these transactions. Let's have a look at the transactions and accounts in Ethereum blockchain. Okay, I have to probably create accounts, make the transfer happens, and then only I'll be able to show you actually the gas price actually which is associated So if I have to do send from one wallet to other wallet, you'll see select fee. Okay, so by default actually the network or probably it will select certain fee which is associated for every transaction to happen. Okay, so if I select actually from one wallet to other wallet who I want to send the address, I have to create a wallet actually for me to show you. Okay, so if I say no, if I have to do transfer from one wallet to other wallet, there'll be a fee which will be associated. By default, it will show a fee. It's always recommended actually that you leave it as it is. What is the fee shown actually against the transaction? If there's an additional fee you end up paying, the remainder would be always be transferred back actually to your wallet, so you don't have to worry about it. So basically, I'm like after the transaction is done, in case there's an additional fee or additional ether which you have transferred by mistake, actually it will always be transferred back to your wallet. so you don't have to really bother about it. It's always recommended actually you select the fee what is shown by default with respect to every transaction which you're doing on the network. Okay, so transactions in Ethereum. So the most notable difference between the transaction in Bitcoin versus Ethereum is that Ethereum block contains both a transaction list and the most recent state of the transaction of the ledger of these transactions. Okay, so let's look at like probably how the transaction and accounts in Ethereum blockchain look like. Okay, the term transaction is used in Ethereum to refer to the signed data package that contains a message to be sent from an externally owned account to another account on the blockchain. Ethereum blocks contains both a transaction list and the most recent state of the ledger of these transactions. Okay, so if you look at it, this is the, let's say, like the previous state. Okay, so here actually you'll see a transaction. Probably this is one transaction is another transaction. It has this transaction has 920. This has 920 ethers, and this has actually like 30 ethers with it. Okay, what you're doing actually, let's say to account whom you're sending to. This is the account to whom you're sending from this account. Okay, or this wallet address. You're transferring actually 10 ether. Okay, what happens? This 10 ether gets added actually to this address. Now it becomes 930 ether, and this account gets debited actually by 10 ether. So now the balance remains is 20 ether. Okay, so accounts are the one actually of the main building blocks of the Ethereum blockchain. Okay, any questions here actually? How approval occurs in Ethereum blockchain? Let's see actually how transactions happen and a block is created in the Ethereum blockchain. Okay, so I think that this is where actually the question what we have actually, how the miners work in Ethereum. Okay, so just like in Bitcoin, transactions are approved by the miners. Anyone can take on the role of a miner and approve the block of transactions. It takes 12 to 15 seconds approximately for a miner to approve or mine a block. Okay, at a theoretical level, a miner performs the following functions: listens for the transactions broadcasted on the Ethereum network, determine the transactions to be processed, determines the stale blocks called uncles and includes them in the block, updates the account balance with the reward earned from successfully mining the block. Finally, a valid state is computed and block is finalized, which defines the result of all state transitions. So mining reward actually, in order to incentivize actually miners for supporting the Ethereum transaction, the block reward is guaranteed to the lucky miners who generate the correct block. Currently, the block reward is set for 5 ether, or it's set at 5 ether for every successful block that is mined. This will contribute to the inflation in the number of ether available and hence the value of each ether. Consensus mechanism in ether. Okay, so for any distributed computing system to properly function, there needs to be a mechanism by which the entire network can come to an agreement on its state, or how its token supply is divided among registered address on the network. Let's see actually how the consensus mechanism is achieved in the Ethereum. So consensus algorithm. At the time of writing actually the consensus, Ethereum uses the proof of work protocol as ETH or ETH, what we call it. Okay, similar to Bitcoin, the core idea behind mining is to find a nonce that nonce hashed. The result is predetermined difficulty level. Okay, it uses actually different cryptographic primitive for its hashing function known as SHA-3 rather than actually the SHA-256 or SHA-256, what we call it actually as well. Okay, so ETH actually is defined to make Ethereum both a resistance to high-powered mining chips that currently dominate the Bitcoin industry and more accessible to light client implementations that allow users to use Ethereum without needing to first download the Ethereum blockchain to their device. Our light client downloads headers of the blocks for reference. Ethereum does far more than processing transactions. So Ethereum blockchain is intended to do far more than process shared transactions. It's designated to execute complex code, which is nothing but your smart contract, where the functionality is only restricted by the imagination of the developers and accessible resources. The complex code are executed in Ethereum virtual machines, which is nothing but the smart contracts. Okay. Ethereum releases Metropolis versus Serenity. Okay, so Metropolis is the next major Ethereum upgrade. Metropolis was introduced on GitHub for testing and it's just a matter of time before it goes live. not only introducing further protocol upgrades and opening the door for Casper, but also new interfaces for non-technical users. This will help. I'm like, so the Mist browser and all actually which is being developed today is under heavy development. Will also come along actually along with the no, along with the Metropolis version. This will help gain further adoption and is also will help the developers create easy to use apps. Okay. Serenity is the last phase in Ethereum network. Release was planned for the start of 2018, but we might have some delays as usually. Okay, Serenity goal is to switch from proof of work to proof of stake by using a method called Casper. Okay, so we'll move on actually to development technique. Okay, or development technologies. Okay, to help network. In addition to the main Ethereum blockchain protocol, there are also supporting technologies in development that seek to help the network and components built on the network run more efficiently. Okay, so supporting technologies, Mist application. I hope you would have seen actually, when you launched or you downloaded actually your Ethereum wallets, you would have seen actually Mist wallets also, or Mist versions also available actually for downloads. Mist is still not ready actually under alpha and beta version of testing. It's still currently being developed. Okay, but then actually the Ethereum wallets actually is built on the Mist browser. Okay, so when you download actually Ethereum wallets, you'll see the Mist browser actually what you see actually on which the Ethereum wallets is built is nothing but the Mist browsers. Okay, decentralized applications are nothing but actually probably what you and I will develop and probably will show one example of ICO. Otherwise basically uh, these are nothing but DAO applications what we call it. Basically decentralized autonomous organization applications. Why I'm calling that? The reason actually you build your own chain, you define the nodes, you define the rules for those nodes actually how we going to govern that chain or DAO. Okay, and that's is done actually in the decentralized applications what you built on the Ethereum blockchain. Swan is the storage where the your ledgers are stored. We heard about level DB, we heard about couch DB and all. We use actually Swan actually in the as part of the Ethereum. Whisper is the messaging actually what we do actually in the peer-to-peer protocols. We heard gossip before actually as part of the fabric, uh, and in case of Ethereum we call it as Whisper. Okay, EVMs is nothing but actually Ethereum virtual machines. These are used actually for run your smart contracts, basically to compile your basically these are independent nodes actually on which you can compile your high level languages to low level languages actually as well. Okay, and to certainly these are independent nodes which are used to reach to consensus, and each independent nodes may have actually smart contracts deployed on them. Okay, the ones actually especially who will be the validator nodes. Okay, hardware clients and the internet actually are the other piece of technologies what you need to deploy your Ethereum wallets, and certainly is built on actually the Web3 technology stack. Best application, okay. So styled as a decentralized application discovery tool, Best is meant to serve as a wallet for smart contracts that features a graphical user interface. A desktop application is used to communicate with each node or with the node, okay. Allows users to dynamically set transaction fees and manage custom tokens. Mist browser versus Ethereum wallet. So Mist is a browser for decentralized web apps. Mist is still in heavy development, is still not recommended to visit untrusted DApps until the fully security audit is done. The current release allows you to open any Ethereum DApp, okay, with the Mist browser. Okay, that's what we have done so far. I mean, the wallets what you have installed is supported on the Mist browser. Okay, Ethereum, the Ethereum wallet, also known as the Meteor DApp wallet. Okay, these releases are decentralized app is what DApp is. Okay, the wallet. The future with Metropolis release will provide the full best browser able to open any DApp available out there. Okay. Ethereum clients, okay, to interact with the contracts. Developers write the contracts which are then converted into the EVM bytecode via EVM compiler and uploaded onto the blockchain using an Ethereum client. There are various clients supporting the Ethereum network. Let's see what clients are and what purpose they serve. Since the start of the Ethereum project, there have been actually multiple client implementations across a range of different operating systems and programming languages. This client diversity is essential for the long-term health of the Ethereum network. So Ethereum clients are software that allows users to approve transactions block, create and manage accounts on Ethereum, send and receive transactions to and from your Ethereum accounts, deploy smart contracts onto the blockchain, mine Ether on the Ethereum blockchain. List of Ethereum clients. So Get is nothing but Golang, which is deployed as a low-level machine language. Supports Go. Ethereum Foundation, at least the developers are Parity. These are some of your clients, okay, who supports the deployment on the Ethereum network, okay. So you can do coding actually any of these, and probably you can deploy your code actually directly, okay. Again, I'm like, okay, certainly Get is one. Apart from Get, actually you can use any of these clients as well to develop and deploy your applications on the Ethereum. But these are actually like, some are high level, some are low level as well.